Hi, everybody. I'm Arvind. I lead the visualization group here at MIT CSAIL. And I'm going to be talking to you about some of the things that we've been working on for the past couple of years, some of it in collaboration with my colleague, Graham Jones, in the anthropology program. So about a year ago, last spring, OpenAI released this demo of using ChatGPT to import and analyze a data set, including producing basic visualizations and explanations of those visualizations. And this demo made waves in my research group Slack because as a group of visualization researchers, we looked around at each other and were like, have we been put out of a job, right? But once the novelty started to wear off, we had a deeper question, right? What we just saw, is this an example of the AI actually doing a good job at helping the users accomplish their task? And this is actually a question that has captivated researchers for many, many years, dating back to the founding of the field. So here is Alan Turing's imitation game. And in the imitation game, what Turing proposed is that a human evaluator would be reading the transcripts of a natural language conversation that occurred between a machine and another person, and it was the job of the evaluator to figure out if they could distinguish which participant was the machine or the human. And if the evaluator couldn't distinguish the two, then the machine was thought to have successfully passed the Turing test. And I would argue that, for the most part, we're still operating under this paradigm of the Turing test. So, for instance, here is a very recent white paper that was written by researchers at Google DeepMind. And in this white paper, they proposed this series of levels to track our progress towards AGI. And at each of these levels, what they are defining is essentially an evaluation of the model's competence, analogizing that to human performance, right? The goal being to see how best the computer might be able to mimic a human's performance, or at that very last level, exceed the human's performance. And I think this is really useful and a really valuable way of thinking about progress, but it also, for me, reminds me of the immortal words of Jeff Goldblum, or even will.i.am, as we just heard, right? It focuses us to think purely about questions of could, right? What are the things we could do, and not so much questions of should. Or put another way, and this is the less catchy way of saying it, right? The Turing test paradigm measures how competently AI can mimic human behavior, but it doesn't help us understand if the AI-driven systems we're developing are actually helping us empower people, or whether these AI-driven systems are actually disempowering us. And so what's an alternate to the Turing test that we might think about? Well, recently, in collaboration with my colleague Graham Jones in anthropology, we've thought about what a renewed focus around agency might look like. And by agency, we mean the capacity to meaningfully act. And by meaningful, we mean the degree to which an action advances an agent's goal. So if we imagine ourselves as just individual people out in the world, we assert our agencies in two ways. The first is we might be composing different kinds of operations in order to produce an action, and then we'll interpret the effect that that action has on the world. And in particular, interpret whether or not we're making meaningful progress towards our goal. Now, as we shift from operating just as individual isolated folks in the community to instead more collaborative relationships, what we start to do is co-mingle our agencies. We start to establish this common ground, this area of overlap, which is a shared understanding of the task, and our capacities for composition and interpretation now are pointed at each other. I'm sure that for many of us who've had long-term, deep kinds of collaboration, you've probably experienced this sort of fusing together, right? This almost mind meld that you have with your collaborators. And that's what I'm showing you here, this essentially fused model of agency that essentially starts to recall another foundational text in this field, Man-Computer Symbiosis, that was written by Licklider right here at MIT in the 1960s. And in this paper, what Licklider describes is to think in interaction with a computer in the same way that you think with a colleague whose competence supplements our own. And so really what I think Licklider is describing is a sense of fusing of a human and AI agent as a sort of fused co-agent like I'm showing you here. And so if we've got this model of agency, let's turn back to that ChatGPT demo and look at where we left off right at the end, right? These set of explanations or plausible explanations that the model gave us. And even if we were evaluated in terms of competence, we might be left wanting, right? So number 2 here is an explanation of the scatter plot of song hotness versus artist familiarity. This shows the relationship between song hotness and artist familiarity. You don't say, right? But I think that these sorts of explanations signal a kind of promise that these models have. The promise being that you could use this generative technology to make visual artifacts like visualizations accessible to people who are blind or have low vision through these kinds of textual descriptions. And indeed, these models have been deployed by lots of different platforms like Facebook and so on to produce little alt-text descriptions of photos. And many researchers have been studying this promise and finding that there's a pretty large disconnect. So for instance, in surveys that my group has conducted, blind participants have told us that they would actually find descriptions like this to be a burden on their reading experience because these kinds of descriptions don't effectively communicate anything about the data. More problematically, others have told us that they shy away from these descriptions altogether because they want to retain a sense of control over how they consume the data. They want to have the time and space to interpret the numbers for themselves before they read any kind of textual analysis. And to me, these sort of responses map quite nicely to those ideas of agency. The first set of responses are perhaps reflective of the model doing a poor job of composing textual descriptions in ways that convey information that is actually meaningful to the user's goals. And the second set of responses suggests that producing just a single static description like the ones we're seeing here aren't sufficiently expressive to help people assert their interpretive agencies, right? We need something more than a single static description. So what's a good way forward? Well, before I show you the things we've been working on, what I'd like to show you is how people who are blind or low vision experience graphical user interfaces today. And to do that, I'm going to turn things over to my PhD student, Jonathan Zong, who's been leading a lot of our work in this area.
A screen reader is an assistive technology that
that's very low volume.
As speech. The software provides a cursor which is shown visually on the screen as a black rectangle. And the user can use keyboard shortcuts to move that cursor and highlight different elements to be read out. I'll demonstrate that with my keyboard now.
Visited link heading level 1. Hi, we're the MIT visualization.
Can we get the volume on the video at all, folks in the back?
Publications, Scase, visited link image, CSAIL logo, heading level 1. Rich screen reader experiences for accessible data visualization.
Okay, so the audio was going in and out. I don't know if you caught that, but essentially what you might have heard was a very rapid narration of the on-screen content, right? And actually, that's a much slower version of what proficient screen reader users actually have the settings set at. But the key challenge here is that the screen reader linearizes the reading order of things that are on screen. And when it comes to visualizations, chances are each of us in the audience here have a different way of reading visualization. Some of us might start with the title and look at the labels and the annotations. Others might focus on the visual content, get an overall sense of the trend, and want to dig into details. So how do we preserve that rich diversity of reading orders, but for people who might be using screen readers? So there's going to be another video with audio. Hopefully the folks in the back will bump up the volume for us this time.
Let's say I'm using a screen reader and I encounter the scatter plot on a page. With Ollie, at first I'll hear an overall description of what the scatter plot is.
A scatter plot with axis split per length, mm, and body mass, g.
Let's say I want more detail about the scatter plot. So I can press the down arrow key and expand this structure to the next level where I can get information about the different axes and legends of the chart.
X-axis titled flipper length, mm, for a quantitative scale, with values from 172 to 231.
And once I'm on this level, I can press the left and right arrow keys to cycle through the other elements on this level.
Y-axis titled body mass, G, for legend titled species, for an...
Let's say that I'm interested in getting more detail about the x-axis, so I can navigate back over to the x-axis with the left arrow key and then press down again to descend into a further level of detail.
Y-axis titled, X-axis titled.
Now down arrow to expand.
1 of 7. Flipper length, is between 172 and 180. 7 values. Press T to open table.
And on this level, I get information about the intervals along each axis.
2 of 7. Flipper length, is between 180 and 190. 3 of 7. Flip 4 of 7. 5 of 7. 6 of 7. 7 of 7.
I'm going to demonstrate here an alternate navigation technique that we're calling spatial navigation. So I'm going to use the WASD keys to move along the grid of the scatter plot.
5 data values in the interval body mass, G, 2,500, 3,000, flipper length, 180,190. 60 data values in the interval body mass, G, 79 data values in the 10 data values in the interval, 25 data values in the 32 data values in the 0 data 3 data values in the 23 data values in the interval body mass, 30 data values in the interval body mass.
So here, by moving around the grid, I'm able to build more of a mental picture of how the data values are distributed spatially.
And so what you're seeing is there's a huge volume of textual descriptions that this system requires, right? And it's not feasible to expect any visualization designer to produce all of those textual descriptions manually. So this is a prime opportunity to engage some generative AI, and the lens of agency forces us to think about what makes it meaningful for the particular task here of exploring this data set. And so I'm going to show you a video from my master's student, Isabella Pedraza Pineros, who's been tackling this as part of her thesis work.
In this version of Ollie, we've added something called data highlights. And if I navigate into the data highlights by pressing the down arrow key, it's going to show us semantically meaningful groupings of data that we've generated through calls to ChatGPT.
Data highlights 4 highlights. 1 of 4. Efficient foragers. This group combines mid-sized flipper lengths with a healthy body mass, indicating penguins that have adapted well to a range of environments, being able to swiftly navigate open waters while also capable of agility. A combination suited for efficient foraging. Flipper length, is between 191 and 210 and body mass, G, is between 3,301 and 4,385 values. Press T to open table. Select.
So in that description, we heard about a grouping called efficient foragers. And the system provided some reasoning about how certain values of flipper length and body mass might indicate that certain penguins are part of this group. And if you look over at the visualization, you can actually see the visual representation of this efficient foragers grouping that we've highlighted to draw an analyst's attention to this grouping of data. We can also explore to find more about other data highlights.
2 of 4. 3 of 4. Antarctic marathoners. Long flipper lengths paired with a robust or athletic body mass may indicate penguins that are specialized for endurance swimming in Antarctic conditions, capable of long-distance hunting in open waters. Flipper length, is between 211 and 235 and body mass, G, is between 4,301 and 6,496 values. Press T to open table.
And so what you are seeing here is that we use ChatGPT to go much beyond just simple textual summaries, right? Instead, we were using it to produce these very semantically meaningful exploratory structures. And in evaluative studies, blind and low vision participants told us that these sort of highlights opened up their minds, made them more interested in exploring the data because it helped them understand the data better. And the sort of hierarchical and spatial navigations that you were seeing before also influence participants' mental models and increase their sense of interpretive agency. So for instance, as this person said, drilling up and down between different layers of the data grid gave them different ways of thinking. And so to wrap up, I wanted to sort of return to that quote from Licklider, right? The ability to think in interaction with a computer. And what I've hopefully shown you is that we're able to do that in a way that preserves people's agency without just relying on a natural language conversation that goes back and forth, right? We can imagine much richer kinds of interactions and interfaces with generative AI. And one of the things I'm most excited about in terms of this model of agency is all the different configurations that it might suggest. So even in this case, for instance, if we wish to stick with a 50-50 blend of agency, research in anthropology suggests that folks in Western cultures might prefer a greater sense of compositional agency versus some indigenous cultures, like the Yopno Valley people in Papua New Guinea, would place a greater emphasis on interpretive agency because that's where they locate a sense of power in communication. Or think about this progression of agency that I'm showing you here, right, where the AI's agency is increasingly encroaching on ours. How worried should we be about this? Right? On the one hand, we might say, well, actually, we want to consider these to be a sort of like milestones in terms of threat levels, right? That the AI is increasingly taking over tasks that we want to maintain control over. But maybe the set of tasks that remains in that blue sphere are the ones that we consider to be the most existentially significant to us, right? Maybe the large expanse of green are actually the sort of mundane, menial tasks that we are perfectly happy to have automated away. And so this is just a tip of an iceberg of ideas that we've explored in this paper right behind this QR code. So thank you very much.